Jeannie, I just spent the whole morning at Douglas Towers. We almost lost that account. Nate Jensen just had to replace a lot of equipment. He blames us for not taking care of his system. Now, in a way, he's right. His system was damaged due to poor water treatment.
It's his own fault. When I brought it up, he said that it was being taken care of. I think he had some contractor taking care of it.
Jeannie, it's our fault. We're supposed to be the experts. We should have checked out the system, and if it wasn't being done right, let him know. Now his equipment is down. There's no guarantee. I explained the situation. We just can't take responsibility for something we have no control over. He finally agreed, but we sure came close to losing him. Jeannie, I guess it's an honest mistake. Water treatment looks pretty small compared to a whole contract, but it can cause big problems. Sometimes a customer thinks he has the situation in hand, but we have an obligation to help him do things properly.
Okay, a customer needs proper water treatment. If we don't include it in a contract, we're not responsible for damage. Now, how do I convince him, especially when he thinks that what he's doing now is adequate?
You have to explain the situation and what will happen if it's not done right.
I'm not sure I can. Seems like you have to be a chemist to understand what's happening with that program.
You know a lot more than you give yourself credit for. There's nothing particularly complicated about water. The problems it causes have always been with us. You've been around this business for a while. What's water used for in building systems?
Transfers heat. You might use it to carry heat from a boiler to an occupied space, or carry heat away out to a cooling tower.
So water circulates through building equipment. Here, let me get something. I keep this stuff around. It's kind of a personal chamber of horrors. Here, take a look at this.
It's all full of rust.
It's corrosion. That's one problem that water can cause. It clogs up the equipment and eats away at components. Here, have a look at that.
This system must have really had problems.
Now, what do you think caused it? Here's another look at the same thing.
You know, that looks a lot like hard water marks in a teapot.
Well, the idea is the same. This is scale. Water is a universal solvent. It absorbs gases from the air and minerals from the earth, keeps them in solution. This is what happens when the concentration of solids is too high. Neglect this, and the system loses efficiency. Heat doesn't transfer properly. Just 1/8 of an inch of scale can increase energy costs by 20%.
Looks like it can plug up equipment, too.
It costs a lot to try to clean this stuff out. Sometimes the only way is to replace the equipment. So we have two problems that water can cause in a system: corrosion and scale. There's one more. Care to guess?
Well, water causes rust. It carries in things with it. I guess what's left is that things grow in it. Algae, maybe?
Sure. Here, take a look at this. Biological fouling clogs up cooling tower systems. If not eliminated, it raises energy costs. And if it's bad enough, it can shut down the cooling system entirely. So problems with water are
corrosion, which can clog up a building system and destroy components. Scale, which increases energy cost, plugs up equipment, and is very expensive to remove, might even force you to replace equipment. And biological fouling, which can clog up tower systems and may even shut down a system entirely.
Right on all counts. You have a good grasp of the problems that water can cause in a system.
Yes, but there are different types of systems and different methods for treating each one. I haven't been able to keep it straight myself, let alone uncomplicate it for a customer.
Well, here, have a look at the pricing sheet. There are basically 3 types of systems: cooling towers, closed systems, and open steam systems. Let's look at them one at a time. Tell me what you know about open systems. What is an open system, anyway?
It's a steam heating system that uses up water. This kind of system utilizes devices that release steam into the air. A steam jet humidifier is one device that can be found in an open steam system. Water is used up in this kind of system. You have to keep adding water to make it work.
Open steam systems were the first kind ever developed. Water treatment started with them. Of the 3 water problems, open steam systems have 2 of them: corrosion and scale. Now, why wouldn't they have biological fouling problems?
No exposure to sunlight, so algae can't grow. Also, the steam is hot, so algae and slime can't survive.
How about corrosion and scale?
Well, corrosion seems to always be associated with water. Scale would probably work here, just like in a teapot. This is an open system, so you use up water and bring in new water all the time. Boil off water and you leave solids. Add more water and you bring in more solids. Boil it off and you increase the concentration.
Right. Okay. The first method of treating water was a mixture of horse manure, potatoes, and the bark of cedar trees. Now, amazingly, this worked somewhat, but tended to clog up the systems on its own, far from the perfect solution. The next thing that was tried was hand-feeding a mixture of phosphates, oxygen scavengers, caustics, and tannins. Unfortunately, unless they were carefully regulated, they caused damage in themselves. Hand-feeding just isn't accurate enough. When you hand-feed chemicals, the balance is incorrect. Either the scale is not taken care of, or the chemicals themselves can cause corrosion.
Now, you mentioned phosphates. Aren't those polluting?
Yes, and that's another concern, especially today. Chromates were also used. They pollute too. Nowadays, in many places, the EPA monitors discharge water to try and stop such polluting. Using chromates and phosphates can cause a lot of problems for a customer.
So chemicals can pollute. And if they're not carefully fed into the system in exactly the right amounts, they themselves can cause scale or corrosion.
Yes. So the next thing that was tried was using a timer to activate a chemical pump. Unfortunately, the addition of makeup water varies with system use. It's added at irregular intervals, not according to some schedule. Timer systems don't take this into account, so chemical levels were still inaccurate. One other thing that was tried was draining off some of the solids in the water, and this is called blowdown. By itself, it only delays scale formation. Solids build up quickly in boiler systems which use a large amount of water. Blowdown must be performed frequently.
Well, okay, so the old-timers used strange and maybe dangerous chemical concoctions. Also, their feeding methods left a lot to be desired. What does that have to do with now?
Well, some people are still using outdated water treatment methods. If your customer is depending on one, he's in for trouble somewhere down the line.
So Honeywell has figured out a better way to do it.
You bet we have. When you bring in a sample of water from the job site, we test that water. For an open steam system, we test for water hardness and alkalinity. This determines the proper chemical to use and its dosage. It also determines the concentration level of solids in the water that can be tolerated without forming scale. We utilize a complete line of non-polluting chemicals. Finally, we use a state-of-the-art metermatic controller system. It measures the volume of makeup water with a special flow meter. It initiates blowdown cycles to maintain a safe concentration of solids in the boiler water. It also operates the chemical feed pump to replace the chemicals lost in the blowdown.
First class, all the way.
Okay, so water treatment began with open steam systems. You following me so far?
Yes. Corrosion and scale are the primary problems, and the treatment must be automatically regulated to match makeup water added to the system.
Fine. Now let's go on a little further into tower systems. Tell me, would you call a system with a cooling tower an open system or a closed system?
Definitely open. Water vapor is being given off into the air as the water is being cooled. I'd guess that you'd have to be adding water to it all the time, although it's used for cooling, whereas a steam boiler system is used for heating.
So you would think that a tower system would have a lot in common with an open steam system.
Yes. You know, I think biological fouling would also present a problem, in addition to the corrosion and scale, I mean. There's plenty of light and exposure to the air.
Sometimes an algicide has to be added to tower water to control biological growth. Actually, two different kinds are used because algae tends to build up an immunity.
Okay, I'm with you so far. Now, are corrosion and scale treated the same as in an open system?
Well, the principles are the same, but there are some differences. For instance, the term for draining off solids in a tower system is called bleed. It's similar to blowdown in a boiler system. Also, a conductivity sensor is used instead of a flow meter to regulate chemical feed and automatic bleed. The more solids in water, the easier electricity passes through it. More solids, greater conductivity. So we can accurately gauge the need for scale protection.
Why don't we use a conductivity sensor in boiler systems? It seems like that would be more accurate.
One reason is that the chemicals used in boiler systems can affect conductivity readings, making them inaccurate. Another is economy. Conductivity systems cost more, but in the case of most boiler systems, are not justified.
Okay, I understand. It's a metermatic for towers.
Yes, but it's called a towermatic. The history of tower water treatment is essentially the same as that of open steam systems, hand feeding and dangerous chemicals. In the Honeywell method, we test the tower water, this time for conductivity. That determines which chemical to use. Then we automatically control bleed and feed with our towermatic system. Algicide is added only as needed, usually during a normal PM if there are signs of algae growth. Algicide amount is not too critical. We just need to avoid wasting it.
All right. tower bleed, boiler blowdown, conductivity sensor, flow meter, tower-matic, meter-matic, exposure to outside, add algicide.
Okay. Now, how about closed systems?
Hot/chilled water or 100% return steam. That's both heating and cooling, right?
Yes.
Well, let's see. Rust is always with us. Water is not normally added to the system, so there's not much chance of a scale problem.
You're right. No makeup water, no scale problem.
Water is not exposed to the outside, so no algicide. The only water problem in a closed system is corrosion.
That's right. To treat a closed system, all we have to do is add anti-corrosion chemicals as needed. We test the water and add chemicals as necessary. And whenever the system is drained down, as it is for inspections, we add chemicals to the new water.
So for closed systems, there's no feed, no bleed, and no blowdown. We test the water and add chemicals as needed. We have to automate open steam systems and tower systems. Closed systems we don't. Simple enough.
Water problems, systems, and treatment methods. If you ever need a refresher, take a look in the service sales manual. You feeling more comfortable with water treatment now?
Yes, but now I have to be able to relate it to what I find on a customer's site.
Well, come on, let's go for a walk. Each time you try to price a contract, you do a survey on the customer's site. That helps you with preliminary price figures. As you do the survey, watch for and note possible water treatment problems.
Such as?
Well, here's one. This boiler is surging. It's also called wet steam, dirty steam, or priming. This indicates high solids in the water, which can cause foaming at the steam-water interface. This allows solids and impurities to be carried along with the steam. In extreme cases, this can shut down the boiler. Proper water treatment could correct this problem. Another giveaway is that the stack temperature is more than 150 degrees greater than that of the steam. This indicates that scale is acting as an insulator. The steam is not heating up and energy is being lost. In a cooling system, scale tends to plug up the condenser. This causes the compressor to exceed its high pressure limit. It shuts down. This is called going out on high head. Do you usually have someone accompany you on a building survey?
Yes, generally a building engineer or someone from the customer's staff.
Good. You could ask him if going out on high head is a problem in the system. If it is, there's probably a problem with scale. Also watch for signs of rust or scale, especially around leaks. Finally, ask about the last system inspection. Scale buildup or rust in the system indicates poor water treatment practices. Look at this. This yellow powder indicates chromate. Watch for it around leaks.
Pollution problem. They're using the wrong chemicals.
Right. Also, if you see an amber color in the water, in the sight glass or in water samples, there may be chromates. In addition to pollution, chromates can cause premature equipment wear. They can damage pump seals. The yellow powder might only indicate that chromates were once used in the system. The amber color may be something else in the water. However, if you find either of them, investigate thoroughly. Check equipment logs or ask the building engineer. In tower water, a green tint means algae or biological fouling. Watch for algae or bacteria. They can grow on any tower surface that is exposed to sunlight. If you notice that a bleed valve is kept open continually, it's a sign of outdated water treatment practices. 1 gallon bleed per minute becomes 1,440 gallons in 24 hours. This is extremely wasteful of both water and chemical. Any existing chemical feed equipment will indicate the type of control being used for water treatment. If there is no equipment, chemicals are probably being hand-fed. Outdated equipment indicates outdated practices. Sometimes the existing equipment is good enough to be used by us. Current water treatment pricing practice makes allowance for that kind of situation.
In other words, keep my eyes and ears open for scale, corrosion, algae, chromates, and outdated practices. Any of these can spell trouble for my customer. He should know about it.
That's right. Well, you've seen everything I can show you about water treatment. Any questions?
What if I can't spot any problems?
Sometimes we run into a situation where water treatment is being done properly. In that case, there's little we can do. However, a customer might still be interested in having us take total responsibility for the building. Now, there are advantages in this, such as having only one person to call for the entire system and having only one billing to keep track of. In any event, it's unusual to find a competitor that offers a service as extensive and complete as ours. Sell the difference. Anything else?
No?
You think you'll be having any more problems in selling water treatment?
Just watch me. Part of this service includes water treatment. This helps safeguard your equipment from corrosion, scale, and biological fouling. These water problems raise your energy cost and repair cost. They cause premature equipment failure and can increase system downtime.
Well, this area's had water problems for years. We've always been doing water treatment. We don't need you to do it.
You know, water treatment is a lot more complex than it seems. There are many ways of dealing with the problem, some of which save you dollars in the short run, but can cause unbelievable problems in the long run. Honeywell has developed effective, high-tech solutions to these problems. Now, generally, we do a building survey before suggesting a contract. This lets us custom tailor our services to exactly suit your situation. We make sure that you aren't buying anything you don't need. So how about I take a look at your present water treatment method during the survey? If it's adequate, no harm done. If it's not, we can save you a nasty surprise later on. What do you think?
Well, it's your time.
Okay, any questions so far?
No, you seem to be right on.
Then let's move on to water treatment.
Oh, now I told you we don't need it.
I understand what you mean. Why pay us to do something that's already taken care of? However, hear me out. I think you might be surprised.
All right, you seem pretty good so far.
Now, you're right about the water in this area. We tested it. It has a lot of dissolved solids. I talked to Bill Evans, your building engineer. Your boiler has had to be cleaned out each of the last 4 years. Scale.
Bill tells me that's a fact of life around here.
Well, it might be. I looked a little closer. Your system is being treated pretty much like you treat the radiator system in your car. Once every year or so, you change the water and put in some chemicals. They have corrosion inhibitors and other things that keep the system flowing freely. Now, here's the problem. You have what is called an open steam system. Water is used up in this building by humidifiers. This means that you are constantly adding water to the system. Follow me so far?
Yeah, go on.
As water is used up, it leaves behind the dissolved minerals that came in with it. You can see this if you boil off water in a teapot. There's a white powder left behind. That's scale. So you use up water and bring more in. The concentrations of these solids increases. Pretty soon you have scale plating the inside of your equipment. As little as 1/8 of an inch of it can boost your energy bill by 20%. It's an insulator which keeps your equipment from moving heat properly.
So it's costing me money.
Twice. First, you lose energy dollars. Then you have to have the equipment cleaned out. That's expensive, too. If it builds up enough, you have to replace equipment. Right now, your boiler has been cleaned out, but the rest of your equipment is getting more and more scale buildup. If you don't stop it, you will be replacing equipment in a few years. You're paying for it right now in your energy bills.
Well, what are we doing wrong?
You're feeding chemicals in by hand. The concentration is wrong. When that happens, either you don't have enough to stop the scaling, or the chemicals themselves are helping to cause damage. You use up water in your system at irregular times. It's almost impossible to get the concentration right when you try to do it by hand.
Well, is there a better way to do it?
Well, as you know, Honeywell has been controlling buildings automatically, state-of-the-art, for a long time now. We didn't leave out water treatment. We have a system called Metermatic, which senses when water is being used and automatically adds the right amount of the right chemical to the new water. No waste, and your scale problem is eliminated. If we treat your system, we will guarantee it. If we fail to treat your system properly, we get the bill, not you.
Does this go for equipment that's already clogged?
Oh, the terms of the contract require that your equipment be brought up to par before we can guarantee it. We can't afford to fix past problems, but we can help you avoid future ones. You need proper water treatment. How about it?
I'm sold. I can't afford not to have it.
Good decision.